Today I am live streaming a problem on spectroscopy. I have already made videos on the different ways in which we do the calculations. You can refer to it once. Now let us start with the problem. These kind of graphs will be provided, like the compound when it is injected into the spectrometer, we get different types of graphs. If we are using UV spectrometer, we get a UV spectrum. The graph will be this kind. If we use IR spectroscopy, we get this kind of graph. If we use HNMR, proton NMR, we get this kind of graph. So these are the different kinds of graph which we get on injecting the sample in the spectrometer. So let us see how to solve the problem or determine the structure of the compound that is unknown by using this spectral evidences. Here this is a problem in which different spectra are provided. First one, UV spectra is provided, IR spectra is provided, and HNMR spectra is provided, and also C13 NMR is provided. Now, using all these 4 different kinds of graphs, we have to determine which compound has been given to us. So let us start with the problem. UV spectrum. Now how to interpret the data? Let us see. No molecular formula is provided in this problem. We have to obtain it, as I said, from the spectral evidences that are provided to us. Now here, in this UV spectrum, you can observe the peak at 102. I hope you can all see this. The molecular ion peak, that is M by E ratio, is at 102. So when we use the rule of 13, that is the value that is given here, it is divided by 13. When we divide it by 13, what we get is 7. So we can calculate a formula of 7, that is C7. If it is C7, we must also know that per oxygen 2 hydrogens are calculated. So we calculate by finding this C7. I'll make another video as to how to do these calculations. Presently, we will focus only on solving this problem. So we get the answer as C7H18. If the peak is at 102, we get this kind of molecular formula. But we are provided with other kind of evidences also. So we have to take into consideration them, all those different spectra, and then finally find out the exact structural formula. Now let us see another graph. I hope you can see this clearly. Now IR spectrum, here it shows a strong absorption at 1740 centimeter inverse. The peak is very sharp over here. If the peaks are very sharp, we say that there is a strong absorption at this region. Now, when we see this kind of sharp peak, it suggests a simple unconjugated ester may be present. So, this we have done. The second thing, simple unconjugated ester may be present in this compound. The next over here at 1200 centimeter inverse, that is over here, this value is 1200. At this point again we can see a strong, but compared to this is a very sharp peak. Compared to this peak is a little broader. So we say it is a strong but a broad peak at 1200 centimeter inverse. I hope it is clear. So if we see a strong and a broad peak at 1200 centimeter inverse, it means, it suggests that there may be a presence of CO bond. So now from these two graphs, we conclude that there is a presence of oxygen, presence of carbon and hydrogen. Now, we must know that for every oxygen we consider it as even. That is, there are two oxygen atoms. It can never be one oxygen. It starts with 2, 4, 6, 8 and so on. So oxygen, in the molecular formulas, oxygen is considered to be 2. So now we know that 2 oxygens are present. So we have used rule number 13 for finding out C7H18. Now we can modify this formula. We got 2 oxygens also, so we have to adjust the oxygens over here. Now to do that, For 2 oxygens, 1 carbon and 4 hydrogens are considered. So now this molecular formula will get modified in such a way that we will adjust 2 oxygens, that is C. In this way we will adjust 2 oxygens, that is per carbon and per 4 hydrogens. So the formula will now change to C5. We will adjust these hydrogens after putting O2. 7. So we have adjusted 2 carbons. Hydrogens, that is like we have got 102. So our molecular formula, the value is 102. We have adjusted C7 plus H18, that is 7 into 12 plus 1 into 18. We are getting the answer 102. Now we have to adjust this 102 in this formula. So we get C5, O2 and H will be adjusted to 10. If we put 10, we will get the answer as 102. I believe you can all hear me. Now, so finally we have found this to be the molecular formula of the compound. Now we can calculate the index of hydrogen deficiency for this compound. That is, just now I told you how to do that. One, that is corresponds to the unsaturation in the C double bond O compound. Take. Now let us see infrared spectrum. Infrared spectrum shows sp3. sp3 means sp3 carbon hydrogen absorption. I'll do it here. This spectrum shows carbon hydrogen sp3 hybridization, that is aliphatic absorption at less than 3000. You can see over here. Over here you can see it is about 2800. I'll bring it a little closer. I believe you all can see. Okay. Here at 3000 centimeter inverse, you can see a CH absorption which is aliphatic, which is having sp3 hybridization. So definitely we can conclude that the molecular formula is C5H10O2. Okay. Now let us see C13NMR. This is HNMR. I'll just take this one. This is C13NMR. Now here it shows a total of 5 peaks. 1, 2, 3, 4, 5. A total of 5 peaks can be seen. Once again I will show. 1. This is the reference point. 1, 2, 3, 4 and 5. 5 peaks are seen. So that is 5 peaks. Now if C13 NMR is showing you 5 peaks, that means there are 5 carbons present. So this is a nice check on our calculation of the formula. We just used rule number 13 and we have found out that it is C5. But when we see C13 NMR, we conclude that definitely it is C5. That is 5 carbons are present. Next, the peak at 174 ppm. It corresponds, this peak, it is 180 over here, this is 180 and 160, in between we are getting at 174. So the peak at 174, it corresponds to ester, that is C double bond O. That is our 5th point. And at 60 ppm, that is this peak, it is de-shielded. This is 80, this is 40, this is 60. I believe you all can see it clearly. This is a little bit clearer one. At 60, the graphs are not very clear, I'm sorry about it. At 60, you can see one more peak. Here there are 2 more peaks. One here and one over here. So at 60 ppm, it shows a de-shielded carbon. Sixth point, this is 174 ppm and at 60 ppm. A de-shielded carbon, not only that, it is neighboring it is neighboring to a single bonded oxygen. It is neighboring to a carbon which is singly bonded to oxygen. And the rest of the carbons, as I showed you here, these are all the rest of the carbons. They are relatively shielded compared to this, the one at 60 ppm. So we could probably derive different possible structures. This is the molecular formula we have derived. Now we have to determine the structural formula. Just finding out the number of carbons, hydrogens and the oxygen is not enough. C5 can be anything. It is a pentacarbon. It can be anything. It may be a incomplete, it may be a compound containing a heteroatom of oxygen, or the oxygen may be outside. It may be outside the ring. It may be a ring atom, or it may be aliphatic. We have not confirmed. Although we are saying that sp3 aliphatic carbon hydrogen bonds are present, but still we cannot be sure that this is the structural formula. By seeing this molecular formula, we cannot arrive at the correct structural formula. So we will derive a couple of possible structures at this point. For that, let us see one HNMR, that is proton NMR also. Let us check what it shows. I hope you all can see. We are having a quartet here, and triplets over here. Okay, so using this integral traces on the spectrum, we can conclude that the peaks shown have the ratio of, this is our 7th point, 2 is to I believe you all can see the graph. 2 is to 2 is to 3 is to 3. Downfield to upfield. These numbers will add up to the 10 total hydrogens. Now, using the splitting patterns on the peaks, we can determine the structure of the compound. Here we can see triplet. Let me try to make the structure. Triplet means it will contain, possibly it will contain at A, you can see a peak over here, and this peak, when it is expanded, but here as it is given, it is written over here triplet, means it is this kind of peak. So if triplet is present, means it is having 3 protons and 1 carbon. So let me try the structure. Possibly it is at A, this is A. At A, I am getting a CH3. So I'll write it as A. Next, at C. At C, it is a quartet. So at quartet, I am getting CH2. 1 carbon is attached to this carbon with the 3 protons, and the same carbon is attached to another single bond. Now let us see again over here. This carbon, probably the downfield quartet at 4.1 ppm, that is D protons, results from the neighboring protons on carbon B. From carbon B, this is formed. So I'll leave this place. Maybe something else is coming over here. So I'll write down about D. For D, I am getting 4.1 ppm. It is formed due to the influence of carbon at B. So it will be attached to carbon at B. So this one is B and this one is D. Now the quartet at C, it is having 2.4 ppm. It results from the proton on carbon A. So C results from A. Therefore, this one is C. Now we have got all of them, A, B, C and D. A, B, C, D. So the structure that remains over here is two oxygens. So one carbon, when we did the derivation, one carbon is having double bonded O, and the same carbon is having an oxygen group. So we have no other place to put, so we will put it over here. So we are getting this kind of structural formula. Let us write it properly. It is CH3, CH2, C double bond O, O, C, H2, CH3. I'm sorry, I didn't write it here. So this is the structural formula. That is 1, 2, 3, 4, 5. 5 means propane. A single bonded O is in between. So it is propanoate. I mean this structure is OH, propanoate. The whole thing is propanoate, and this is the ethyl group attached to this. So it is ethyl propanoate. Now here, one interesting thing I'll show you. That is the UV spectrum. It is almost everything is not given over here. There is hardly anything which can be of any interest in this. It is uninteresting. But because of this M102 peak that is being provided, it supports the identification of structure, probable structure that can happen. Now simple esters, they will have weak pi star bonding. We have found that it is a simple unconjugated ester. They have weak pi star transition at 205 nanometers. Which is very much near the solvent cutoff point. So we come to the mass spectrum. It shows a strong peak at 57 mass units. Over here, 57, which results from an alpha cleavage. of an alkoxy group to yield an acylium ion. What is an acylium ion? CH3, CH2, C, this one, double bond O. Now this, since it is having one bond less, so it is a ion. Now this, if we count the number of carbons and hydrogens, that is 12 plus 3 plus 12 plus 2 plus 12 plus 18, we get the mass atomic weight to be, molecular weight to be 57. So 57, it is showing the peak over here. That is only the thing that we can use from this UV spectra. That is it for this video. I'll also make the same problem in Hindi. I'll take up another problem in some time. Please be connected. Thanks for watching.